Today, we'll be talking about electrolysis. The objectives of this video is to 1. Define electrolysis. 2. State the terms used in electrolysis. 3. Define electrolytes. 4. Explain the concept of electrodes. 5. Give a typical illustration of an electrolytic cell. And 6. Explain the electrolysis of brine solution. Now, let's define electrolysis. Electrolysis is the chemical decomposition of compound, which takes place when an electric current passes through either a solution or the molten form of the compound. Various terms used in electrolysis include 1. Electrolytes, 2. Electrodes, 3. Anode, 4. Cathode, and 5. Electrolytic cell. Now let's talk on electrolytes. Electrolyte is a compound either in solution or molten form which conducts electric current and is decomposed at the electrodes in the process. For example, we have acids, alkalis, and soluble salts. Two, electrodes. Electrodes are conductors, either poles of carbon or metal, through which an electric current enters or leaves the electrolytes. 3. Anode. This is the positive electrode by which electric current enters the electrolyte or by which electrons leave the electrolyte. Cathode. Cathode is the negative electrode by which current leaves the electrolyte or by which electrons enter the electrolyte. Five, electrolytic cell. This consists of a container of electrolytes with two electrodes connected to a suitable direct current supply.
Used in electrolysis, and we talked about electrolytic cell. What we have here is a dissociation of an electrolytic cell. We have the battery, which has the positive and the negative terminal. This carton here is a suspender. It is just an improvisation. We have these two pencils, but you know that what you have, the black substance you have in a pencil contains lead and it is carbon. And what we have in this solution, this is a solution of sodium chloride, or you call it brine solution. It's a concentrated solution. When you have your suspender, you put it into your solution, then you have your battery connected, perfectly connected to the lead in the pencil. Then all what you have now is that it is what? An electrolytic cell. We have our salt inside, that is the concentrated sodium chloride, or you could also call it a normal table salt. Now I explained earlier on that before an electrolytic cell can be a complete electrolytic cell, your cathode and your anode must be connected to your what? To your battery, or it's a power supply or a power source. Now, in the electrolysis of brine solution, when you connect your battery to your cathode and your anode terminal, there is going to be dissociations of ions. In electrolysis of brine solution, we have sodium, chloride, and water. Now, when they dissociate to form mobile ions. And the mobile ions that are there are what we have. We have sodium ion, we have the chloride ion, we have the hydrogen ion, and we have the hydroxide ion. Sodium ion and hydrogen ion are electropositive ions. In the electrochemical series, the electropositive ions, sodium is first before hydrogen ion. But when we talk about preferential discharge of ions, hydrogen is going to be preferentially discharged over sodium. Why? Because sodium is much more electropositive than hydrogen. Sodium readily gives out electron, and because it readily gives out electron, it will be very difficult for you to accept electron. But in terms of hydrogen, hydrogen gives out electron as well, but is in least in the electrochemical series. It is lower in the electrochemical series, meaning it does not readily give out electron. Now, since we know that hydrogen does not readily give out electron, then there is a very great tendency for hydrogen to do what? To accept electron. So now when we have that, we have in the electropositive ion, sodium ion, and hydrogen ions. Now in the electronegative ions, the mobile ions that will be found in this solution is chloride ion and hydroxide ion. When we come to chloride ion and we come to hydroxide ion, in terms of electronegativity, hydroxide ion is first in the electrochemical series in electronegativity, while chloride ion is lower in electrochemical series. Now, because we know that hydroxide ion is first, meaning it does what? It readily accepts electron. It has the least tendency to do what? To give out. But when you look at hydrogen, when you look at chloride is least. It does what? It has the tendency to do what? To accept electron, but it's a least tendency. So therefore, hydroxide ion, we have a higher tendency to what? Accept electron. Now, what happens in the electrolysis of brine solution? When your sodium ions, and we have what? Hydrogen ion, and we already know that the sodium ion will be what? Preferentially discharged. What happens when it is preferentially discharged? It loses its ion state. It loses its state by doing what? By accepting electron. And when it accepts electron, it becomes discharged. It becomes a metal on its own. And now when we go to that of chloride and hydroxide ion, chloride ion does what? It accepts electron and becomes discharged. And by accepting electron and becoming discharged is in its normal state. So now what happens in the solution? By the time sodium is being discharged, sodium moves. We have what? They become what? Mobile ions. Sodium moves, and when it moves, what do we have now? By the time sodium moves, then hydrogen. Sodium is left in the solution and hydrogen moves. For you to know that hydrogen is preferentially discharged, you're going to see bubbles. Now, if you look carefully, you see bubbles. If you look carefully, you see bubbles in the solution at the tip of the leg inside. You see bubbles. Those bubbles you see, it's significant to show that hydrogen is present. Hydrogen is being what? Given off. And now when you look carefully again, chlorine gas is also what? Is also what? Discharged. Is also what? Giving off. So for you to know that hydrogen gas is giving off, you're going to see bubbles around the edge of the lead. You are going to see bubbles around the edge of the lead. Now what happens? What is left in the solution? What we have left in the solution is what we call sodium hydroxide. And now sodium hydroxide is what we popularly call lye. And if you notice that most relaxers that we make use of, you see that some of them contains lye. And this lye, you see L-Y-E, lye. This lye, you see, is as a result of what? Electrolysis of brine solution. What is left in the solution? And lye is used in cosmetics industry for production of what? Relaxers. And if you notice that you see most relaxers, you notice that they write no lye condition, meaning there is no what? Sodium hydroxide inside. I'm sure with just this little experiment, you've been able to understand the electrolysis of brine solution. Remember I said earlier, electrolysis of brine solution, it has to be what? Concentrated brine solution. Electrolysis of brine solution, the hydrogen is preferentially discharged over sodium, and when the hydrogen is being preferentially discharged over sodium, we have the sodium left in the solution. Now in the electronegative part, the chloride is preferentially discharged over hydroxide ion, and we have what? The hydroxide ion left in the solution. And what we have left, when you add sodium plus hydroxide ions, what we have left in the solution is what? Sodium hydroxide, and it is popularly called what? Lye. Now for you to know that hydrogen is being evolved, you see what? Gas around the lead solution, around the lead material or the lead, the pencil. You see it there. I'm sure with just this very little experiment and the improvisation of it all, you've been able to understand electrolysis of brine solution.